What's up, guys? So we have got functions here. So we've got two types of functions, which is the hyperbolic function and the straight line function. So let's start with the question. So the question says the given is f at x is equals to 2 over x minus 3 minus 1. So that's my hyperbolic, and we've got g at x is equals to x minus 3, and that's my straight line function. So the first question is write down the domain of f, right? So they are asking for the domain of my hyperbolic function. So we know that the domain of a hyperbolic function is always x is an element of real numbers, right? But then my x can never be equal to my what? To my asymptote. In this case, my asymptote is 3. That's the first answer to 3.1. And then 3.2, we've got, it says calculate the x-intercept of what? The x-intercept of f. So we know when calculating the x-intercept, right, for any function, we just say x-intercept and we set y to what? Y to 0. So there's gonna be 0 is equals to 2 over x minus 3 minus 1, right? So just basic algebra, and it's gonna be 2 over x minus 3, x minus 3 is equals to 2, and then x is equals to 5. So my x-intercept is equal to 5. And then we've got my 3.3 says draw the graphs of f and g on the same system of axes, right? Clearly show all intercepts with the axis as well as the asymptotes, right? So in order for us to draw this graph, we still have a few missing things from both the graph of f and both the graph of and also the graph of g, right? So from the graph of f, what's missing, right? Let me just do this. Okay, so from the graph of f, we already have its x asymptote, its x value, which is x is equal to what? X is equal to 5. So what's left for us is to determine the y value. So how are we going to determine the y value? So when determining the y value, the y-intercept, we just set x to 0, right? So it's going to be y is equal to 2 over 0 minus 3, right, minus 1, which is negative 5 over 3, right? And then in decimal form, it's negative 1,67 rounded off, right? So my y is negative 1,67. The reason I rounded it off into decimal form, it's because when I'm gonna be plotting, I wanna know where it is exactly on the axis. So these are my intercepts for f, right? But then we also have to go determine my asymptotes. My asymptotes are quite easy to determine. So my first asymptote, my vertical asymptote is going to be x is equals to what? To 3. And my horizontal asymptote is going to be y is equals to negative 1. These are my asymptotes. So we also have to go determine the x-intercept and the y-intercept of g. So the x-intercept and the y-intercept of g are quite easy to find because we just do the same. We say y-intercept, meaning we say x is equals to 0. So x is equals to 0. Then so it's gonna be y is equals to, let me do the calculations here. Y is equals to 0 minus 3. So y is equals to negative 3. So my y is equal to negative 3. And then my x-intercept, I just do the same. X-intercept, you set y to 0. Y is equals to 0. So it's going to be 0 is equals to x minus 3, meaning x is equals to 3. So my x is equals to 3. So right now I have everything that I need to plot my graphs. So I'm just going to create space for us to plot those graphs. Okay, so let's start plotting our graphs. So my graph, it's gonna be something like this. um, yeah, I think something like that too. Okay, there's gonna be -1, -2, -3, -4, -5. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. -1, -2, -3, -4, and -5. Right. So the first thing that you should do, right, is to plot in your asymptotes. In this case, my asymptote is x is equals to 3. So I'm just gonna go where x is equal to 3. It's here. So that's my first asymptote. My vertical asymptote is x is equals to 3. Okay. And then my horizontal asymptote is y is equals to -1, right? So I'm just gonna go where y is equal to -1. It's here. So those are my asymptotes. And then we're just gonna uh, write down the equations of my asymptote, which is x is equals to 3 and y is equals to -1. Okay. So let's start by plotting my f. So what are my intercepts for f, right? So my x-intercept is equal to 5, so it's somewhere there. Then it's gonna go something like this. Go something like that. Then it's gonna continue that side, right? And then my y-intercept, it's -1,67, so it's somewhere here. See, I'm just estimating, but then because it's a decimal, so okay, it's gonna continue that side. And then I'm just gonna name my coordinates. So this is 0 and -1,67. But then it's advisable to write it as a fraction. The fraction that you got at first, it's advisable to write it as that fraction because it's more accurate. You understand? I just did this for the purpose of trying to plot where it's gonna be on the axis. And then that side, I'm gonna have 5 and 0. Cool. So this is my hyperbolic function. And then to my straight line function, I have the intercept. So my y-intercept is -3, so it's somewhere here. And my x-intercept is 3, so it's directly on my asymptote. So let me try to make this straight. Yeah, I think that will do. And that's it. It's just gonna continue. Okay, this is my point. This is 0 and -3, and that's 3 and 0. Okay, so that's my graph there, and 3.3 is done. 5 marks in the bag. So we're gonna go to 3.4, right? So 3.4, it's 4 marks, right? So 3.4 says calculate the values of x, right, for which, right, for which f at x is my hyperbolic function, is greater than or equal to g of x, right? If x is greater than or equal to 3. So basically what they are asking here, right, they are looking for my graph of the hyperbolic function where it is above my graph of the linear function. You understand that? So we're just gonna look at this graph, right? I'm just gonna use a blue color to indicate what I'm gonna, a red color actually, to indicate what I'm gonna be doing now. So we are looking for places where my hyperbolic function is above my what? My linear function. but then we are given a restriction on where to look, right? So they said we should, if x is greater than or equal to 3, right? So they said we should start looking from x is equal to 3 up until what? Up until positive infinity, right? So looking at this, right, let's look from where x is equal to 3 up until to wherever, right? So my first place where I'm going to look at is this part, right? So looking at this part, we can obviously see that my hyperbolic function is above my what? My linear function up until here. So from this part up until this part here, my what? My hyperbolic function is above my linear function, right? But then from this part up until positive infinity, we can see that my linear function, this graph, is always going to be above my hyperbolic function. So this part I don't want, but then this part, this first part, is a part which I want, right? But then we also got a problem because we do not know what the value is here, where the two graphs of f and g intersect, right? We don't know that value, right? So we first have to determine what the value is at that point, and then we can therefore conclude with an answer. But then note this, you only have to find the x value at that point, and there's no need for you to find the y value at that intersection point, because right now we are looking for values of x, right, where f at x is greater than g of x. So finding the y value does us no good. It helps us in no way, but then it's just a good practice way of learning these things. You can also do it if you feel like doing it, but then in this video we won't be calculating the y value at that point. So let's get started. So we are looking for a place where f at x is equal to g of x, right? So we're just going to equate the two equations. So we're going to be equating 2 over x minus 3 minus 1 equal to x minus 3, right? So it's just basic algebra from here. 3 is equal to x minus 2, right? And then you cross multiply, you're going to have 2 is equals to x minus 3 into x minus 2. This is what you're going to have. And then your final product you're going to have, let me just take 2 to the right hand side permanently. So you're going to have x squared minus 5x, and then the 2's, right, the 2's, it's going to be minus 6 minus 2, right? Plus 6, I mean, not minus. So this is going to be minus 2, and then let me just create space this side. So if we try and simplify this further, it's going to be x squared minus 5x plus 4 equals to 0, and then we factorize. So this is going to be x, and then 4, 1, minus, minus. So x is equals to 1, or x is equals to 4, right? So we obviously know that this one belongs to this point. So the x value at that point is what? Is 1. But then the x is equals to 4 belongs to this point. So the x value at that point is what? Is 4. You understand that? So right now we've got the x value at that point. We can now conclude with our answer. So if you look at this thing properly, right, x should be in an interval. You understand that x should be between two numbers in order for us to satisfy the condition that they are looking for, which is f at x is greater than g of x if x is greater than or equal to 3, right? So we know that x should be between an interval, but then where is my upper bound? Where does x stop being greater than, like, where does x start being below g of x, right? So x starts being below g of x when x is greater than, what? 5. So we want where x is less than or equal to what? To 4. This x value at that point, because at 4, right, at 4 f at x is equal to g of x, and remember that equality is also part of the condition that they said we should have, right? And then x should be less than or equal to 4, right? But then we can just say x should be less than or equal to 4, because if we say this, we are inferring that from 4 up to negative infinity, right, my hyperbolic function will always be above my what? My straight line function, right? So, which is not true. So from this point to this point, right, it's always going to be above. So this side we're just gonna say x should be greater than what? 3. We do not include 3 because 3 is an asymptote, and g of x can never be equal to f at x at an asymptote, because f at x is a hyperbola, right? But then we are not done, because we only treated one side of the graph. Now we have to treat the other side of the graph. I'm going to use a blue color. So this is my first solution, right? But then check, from this side going there, from this side going there, we will not treat because of this condition. I almost forgot the condition because I was almost going to give the answer to the interval going that side. Okay, but then it means our solution is finished because of the condition of if x is greater than or equal to 3. So therefore my answer for 3.4 will be x should be less than or equal to 4, but then x should be greater than what? Greater than 3. So I hope you guys understood the question, and I hope you like, subscribe, comment, and share, and I'll see you guys in the next video. Thank you.